everyone, I'm Tim Kington and this is Java for Beginners. Daisy decided to join us today. She was unhappy with how I did last time, so she's going to keep an eye on me, make sure I get things right this time around. Last time we talked about how to get Visual Studio Code set up, and then we took a look at creating a Java project and running a simple program. Now we're going to talk about variables, and we're also going to look at how to read some input from the user so we can make our program interactive and a little bit more interesting. I've created a project to start with, just like we did last time. So we have our basic main method that Maven creates for us. Let's talk about variables. So a variable is a box that we can store a value in. In our programs, we're going to want to read input from the user, or maybe read data off of the disk, or receive data across the network. And we're going to need a place to keep that data and then refer to it later in our program when we want to manipulate it. Maybe we want to do calculations with the data. Maybe we want to send it off to another place. We read it from the user and save it into a file, something like that. So we need a way to store data and we need a way to refer to it by name. And that's what variables let us do. Now in Java, we have a handful of primitive data types, and that's all we're going to be focusing on right now. The simplest type, and the most commonly used, is called integer. And in Java, we specify that with int. So when we define a variable, we're going to give the type of the variable, and then we're going to give it a name. And then we put a semicolon on the end of the line. You're going to notice that almost every line of code in Java has to end with a semicolon. So here we've defined a variable called x, and it can hold an integer. If we hover over this yellow squiggly here, we'll see that we're having a warning because the value of the variable x is not being used yet. So the compiler's telling us you've got this extra variable around, but you're not doing anything with it. Now we can assign to a variable with the equals operator, the assignment operator. And assignment goes from right to left. So here we could say x equals 3, say. Now at this point, x is a box that can hold a number, an integer, so it means a whole number. And we're assigning it the value 3, so now x holds the value 3. And it turns out that system.println knows how to print lots of different types of data. So last time we were printing strings with it, but we can also print an integer with it. So let's put x in here instead of our hello world. And then let's go ahead and run our program. And you can see Maven builds it, and then it prints out 3. So we created a place to store a number, we put the value 3 into that variable, and then we printed out the value of the variable. We can also define and initialize the variable in a single line. So I could say int x equals 3, and that would be the more common way of doing this if we're going to initialize it right away. And this would work exactly the same way as before. Now, once we've created a variable, its value can change over time. So here we could reassign x to hold a different value, and then we could print it out again. So if I run this program, we're going to see it prints 3, and then it prints 5. So up here, x has a value 3, then it has the value 5. Let's look at some of the other data types we have available. If we want to store numbers that have decimal parts, fractional parts, then we can use the type double. So for example, if we wanted to store pi, we could say double pi equals 3.14. And you can print this out just like we did with an integer. Systemout.println knows how to print pretty much any type in Java. We also have Boolean variables. Boolean is a true-false value. So Boolean B here can be either equal to true or equal to false. And when we print this one out, it will actually print as the word true or false. So if we run this, see, we can print our double and we can print our Boolean value. And then the other type we're going to be using all the time is string. Now a string is not really a primitive type, and we'll talk about what a primitive type and what an object type is a little bit later on. But strings act almost exactly like primitive types. So for now, we'll use strings and we'll pretend they're primitive types. And then a little bit later, we're going to talk about the differences and why strings aren't really primitives. We can say string s equals, and then strings in Java are going to be enclosed in double quotes. All right, so we can assign a string variable like this, and if we print it out, as you would guess, it's going to print a word. All of these variable types are defined in the same way. We're going to give the type of the variable, the name of the variable, and then an optional initialization clause. We can put an equal sign and then the value that we're going to store in that variable to start with. We can reassign variables over time. What happens if we try to assign a value that is the wrong type for a variable? Well, let's say that we said x equals s. Now remember, assignment in Java is going to go from right to left. So we're going to take the value in the variable on the right side, and we're going to copy it into the variable on the left side. All right, so here we're trying to copy the string that is inside the variable s, so a word, into x, which is a variable meant to hold an int. You can also check your types. If you hover over these with your mouse in VS Code, it will tell you the types of the variables. And also when we get these red squigglies, this is telling us that we have an error, and hovering here will tell you what the error is. So it's telling us right now we cannot convert from string to int. There is no conversion there, right? We can't convert this string into a number. So Java doesn't like that. We can assign from one integer variable to another. So if we define a second integer, int y equals 6, and then we assign it to x. So remember, assignment goes right to left. So we're copying the contents of y into x. So 6 into x. We can then print out the value. And since we have so many output statements here, we'll say x is, so that we can keep this straight. And then we'll print x. And if we run this, then we see that at the end of our program here, x is 6. So originally x contained the value 3, then it contained the value 5. Then down here we copy the value 6 from y to x. What happens to y when we do that? Well, let's find out. Gesundheit. You probably can't hear that. Daisy is sneezing up a storm. Y is still also 6. So when we do this assignment, we are copying the value from y into x. It doesn't affect y. If we try to copy from a double into an int, or an int into a double, something different happens. So if we say pi equals x, this works. The compiler doesn't complain here. And if we print out pi, we'll see that its value has changed. When we do this assignment, an automatic type conversion is happening. So x was an integer, pi is a double, and as we copy the integer 6 into a double, we need to turn it into a decimal number. So it becomes 6.0. If we try to go in the opposite direction, x equals pi, now we get an error. That's because pi can have a fractional part, so it could be 3.14. And we're trying to copy it into an integer, and we're going to lose that 0.14 if we do that assignment. So we can again try to print out x here, but this line of code doesn't compile right now. When we hover, it says cannot convert from double to int. Now if we do want to assign from a double to an integer, VS Code's offering us a quick fix here. We can add a cast to int. If we do that, it's going to insert this cast. So when we put this int in parentheses here, what we're saying is take pi and convert it to this type. So it's going to convert from double to int, and then we can assign to x because the value is now an int. When we convert from double to int, it's going to throw away the decimal part of the number. So here we had 6.0, so we won't be able to tell anything happened. Let's change pi first. We'll say that pi is 1.23. Then we're going to convert it to an integer and assign it to x. So it's going to throw away the decimal part, 0.23, and just assign 1 to x. And so we can print out both values. So pi is pi and x is x. And if we run this, we see that pi holds the value 123, and when we assign it to x, that number gets converted to 1. Let's look at one more thing here. Let's look at how to read some input from the user. Our programs really aren't going to be very interesting until we can interact with the user in some way, or at least with the outside world. There is an object called a scanner, and we're not going to worry about the details of this too much right now. I know I keep saying that. I'm going to say that a lot. So we're going to create a scanner which lets us read input from the user. So scanner in equals a new scanner, and we're going to give it system.in. And for now, we're just going to think of this as a magic incantation that will create a scanner. And later on, we'll talk about what the different parts of this line of code mean. Right now we're getting an error. It's telling us that the scanner cannot be resolved to a type. The types that we were using before, like int and double, are built into the Java language. And system.out, which we were using to print things on the screen, is automatically included in every program that we write. There are lots of other utility classes that we can use in Java, but they're not automatically included into our program. So when we want to use one of those, we need to import it. That's what we forgot to do here. So it's telling us it doesn't know what scanner is. There is a quick fix that VS Code suggests, import scanner from java.util, and that is what we want to do. So there's a package called java.util that contains this useful class called scanner. And when we add this line of code to our program, we're telling the compiler where to find that scanner so that we can use it. So now we're creating a new scanner, and we're assigning it to a variable in. So this part of the line we already understand. This works just like the variable declarations we just looked at. We have the type of the variable scanner, and then we have the name of the variable. I'm calling it in. We could call it anything we want here. But since I'm going to use it to read input from the user, I'm calling it in. Now the scanner has some useful methods on it, and we can use it to read input from the user. So we could say something like, we're going to define a variable that is a string called name, and then we're going to say in, and it has a method called nextLine. Notice that VS Code is being helpful here. When we say in dot, it starts to show us all the things the scanner can do. And as we type, it narrows down the list to things that match what we've typed so far. So I want nextLine, and we need a semicolon at the end of the line. So in.nextLine is going to read one line of input from the user, and then whatever the user enters is going to be assigned into this string variable called name. So let's ask the user for their name here. So we'll print, what is your name? Then we're going to read a line of input and put it in the variable called name. And then we'll print out hello and the name. And then we still have a yellow squiggly up here, which is a warning. It's telling us that in is never closed. With a scanner that's reading from the keyboard like this, we don't really need to close it, but I'm going to put in a call to in.close just to get rid of that warning. All right, so we're going to consider this line and in.close to be magic for now. I'm not going to worry about how those work. This prints out what is your name. This is going to use our scanner to read a line of input, and then we're going to put it in the variable called name, that is a string, so it can hold a string of characters. Then we're going to print hello, and then we're going to print the name. So let's go ahead and run this. And we'll put in a name and hit enter. And then it says, hello, Tim. So suddenly we have a lot of power, right? We can read from the user. We can print values out based on what the user entered. We're starting to be able to write an interesting program. We can also read other types from the user. So let's ask for a favorite number. This time we're going to be reading a number, so we want to store it in a variable that is an int. So we'll say int, and let's just call it favorite number. This is the normal style for naming variables in Java. It's called camel case. We're going to make the first word lowercase, and then every subsequent word is capitalized. And we can use our scanner to read a number. Now, if we use nextLine, that's going to return a string, but we can use nextInt to get a number from the user. So this will read a number and then assign it to our variable favorite number. And then we can print it out to prove that it worked. Notice how helpful VS Code is. It really wants to save us typing. As soon as we start to type the name of the variable, it displays that name for us, and we can hit enter to complete it and save ourselves some time. All right, so we print what is your favorite number. We're going to use the scanner to read an int from the user, stored in a variable called favorite number, and then we'll print your favorite number, and we'll print the number that was entered. So let's run this. It's still asking for our name. Okay, my favorite number 13, and then it prints it back out for us. That works well. When we ask for a name up here, the user is going to enter a string, and there's really no way to do that wrong. When we ask for a favorite number, the user might not cooperate. So if we run this again, and this time for my number, I put something in that is not a number, that causes a problem. So this in.nextInt is going to blow up because it can't find an integer from the user's input. It reads this not a number and cannot convert that to an int. We're going to get an error that looks something like this. We're not going to worry about exactly what exceptions are right now, but just know that when something goes wrong with your program, you'll see an error that looks kind of like this. And in this case, it's pretty easy to figure out what went wrong. The user entered not a number, so pretty easy to tell. But this is how you know that something broke as your program was executing. Today we took a look at some of the primitive types we have available in Java. We talked about how to declare variables and assign values to them. And then we took a quick look at the scanner object, which lets us read input from the user. Next time, we'll talk about operators and expressions, which will allow us to do some calculations with our data. Don't forget to like and subscribe.